The reason why aircraft, weighing tens or even hundreds of tons, can fly lies in advanced engines and sophisticated aerodynamic design. Modern commercial aircraft commonly use turbofan engines. Air is first drawn in by the fan blades and then split into two streams. One flows directly towards the rear through the bypass duct, while the other enters the compressor. The compressor is cleverly designed, using a special combination of blade angles to continuously deflect and compress the air. Why is it necessary to compress the air? Because as altitude increases, the oxygen content in the air decreases, making it difficult for fuel to burn effectively. The compressed air is thoroughly mixed with aviation fuel and ignited in the combustion chamber, producing high-temperature, high-pressure gases that drive the turbine to rotate, ultimately generating strong thrust. It's important to note that since the turbine and compressor are connected by the same shaft, the turbine's rotation further boosts the efficiency of the compressor. The air flowing through the bypass duct isn't just there for show. It helps cool the engine and allows unburned fuel to ignite again, generating even more thrust without increasing fuel consumption. However, strong thrust alone is not enough to make an aircraft fly. It also requires an aerodynamic shape, especially in the wings, which are designed so that the air flowing over the top surface travels a greater distance than the air below. This means the airspeed above the wing is faster. According to Bernoulli's principle, faster airspeed results in lower pressure. Therefore, a pressure difference is created between the top and bottom of the wing, generating lift. When the lift exceeds the aircraft's weight, the plane can take off. So, how can lift be increased to surpass the aircraft's weight? Aside from increasing engine thrust, there are two main methods. The first is by adjusting the flaps and slats to increase the pressure difference between the top and bottom of the wing, thereby enhancing lift. The second is by increasing the angle of attack. By controlling the elevators, the nose of the aircraft is tilted upward, increasing the lift generated by the wings. Now let's look at the process of an aircraft from takeoff to landing. During takeoff, the pilot starts the turbofan engines, accelerating the aircraft. Then, the pilot adjusts the flaps and slats to increase the wing area and lift. When the speed reaches the required takeoff velocity, the pilot pulls up the elevators to raise the nose. As the lift increases, the plane slowly leaves the ground and begins to climb. After reaching a certain altitude, the pilot retracts the landing gear and adjusts the flaps, slats, and elevators to balance the lift with the aircraft's weight, achieving cruising flight, which reduces fuel consumption. It's worth noting that an aircraft doesn't turn solely by using the rudder, as this would generate strong centrifugal forces. Instead, the pilot controls the ailerons to make one wing generate more lift than the other, causing the plane to roll or bank, which increases centripetal force. To avoid side slip, the pilot simultaneously adjusts the rudder. During landing, the pilot gradually reduces engine thrust, allowing the aircraft to descend at a controlled angle. Upon reaching the landing altitude, the pilot adjusts the flaps, slats, and elevators and extends the landing gear, allowing the plane to gently touch down on the runway. To increase drag, the pilot deploys the spoilers on the wings and activates the engine's thrust reversers. Thrust reversers don't reverse the engine's rotation. Instead, they redirect some of the airflow forward, shortening the landing distance.